welcome back. And today we are going to discuss about the interface segregation principle. So you know that in this playlist we are going to discuss about we are discussing about the solid use principles. So among these solid use principles, we have discussed till now about the SOL, which means single responsibility principle, open close principle, and the list code substitution principle. And in this video, we are going to discuss about the interface segregation principle. Right. So as of now, in these videos, we are going to discuss about the theoretical part of these principles, and basically we are making our understanding in these concepts. And later on, once all these concepts will be discussed, after that we will be discuss it with respect to the code as well, right? So we will write some code and how to write such code, what the code will look like if we are following these principles, that we will be discussing later on. So let's start with the interface segregation principle. So it is a very simple statement that in case you have to make your code maintainable, and if you have written the interface in your application, then your interface should be written in such a manner that the client means whosoever is implementing that interface, they should not be forced to implement an interface which is not needed by him. Or you can say they should not be forced to implement those methods which the client does not need. You know that in interface there can be number of methods, okay? A, B, C, D, E, F. Suppose there are these 6 methods, right? And someone is going to implement this interface. It may be that only 4 methods, A, B, C, and D. These 4 methods are needed by the client. But still, in case you are implementing some interface, then you have to implement those methods as well. Whatever methods are there, all those methods you have to implement inside your class. So you are forced to implement those methods which are not needed exactly by you, right? So these kind of interfaces are known as the fat interfaces. An interface segregation principle is the solution, or you can say is the answer to this kind of situation, this kind of code which is unnecessarily complicated, which is unnecessarily unnecessarily forcing you to write some piece of code which is not exactly needed by you, which is creating a kind of issue where the code will be less readable, right? It will be not making much sense, right? So in such cases, see, these kind of interfaces are known as the fat interfaces, where the extra fats, which means the extra methods, are there and you have to remove those methods. That is the solution of this problem. And when you solve this problem, then you are following the interface segregation principle, and then your code is following the object-oriented principles, which are the object-oriented OOPS principles, which are the solid principles. And one of the principle is interface segregation principle. So if you want your code to follow interface segregation principle, you need to remove the extra fat, which means the extra methods that you have written in your interface, you have to remove them. You have to break your interface into 2 separate interfaces. So do you remember, can you recall, there was a similar principle, just like the interface segregation principle, but that principle was applicable to the classes. That principle was not applicable to the interfaces. I hope you might be able to recall it. That principle was single responsibility principle. So basically this interface segregation principle is nothing but a variation of single responsibility principle for the interfaces. That's it. That's the variation of the single responsibility principle. Interface segregation principle, I repeat again, interface segregation principle is just like the single responsibility principle, but the only difference is that single responsibility principle is applicable to the classes, but interface segregation principle is applicable to the interfaces, right? So let us see, there are few points I have written here. So there could be interfaces which have extra methods which need to be implemented by some classes. Rather than interface, I should write classes, but not by others. Such interfaces are known as the fat interfaces. The objective of this principle is to remove the fat from an interface and write interfaces which only contains methods relevant to one responsibility, and they can be implemented by the clients. Okay. So suppose there is now let us see an example. So suppose there is a interface which I have written, which is known as the worker. There are 3 methods. One is calculate pay, the other method is assign work, and the last method is assign leaves, right? So if we see closely, then this worker interface looks perfectly fine. in case we have any organization where all the workers are the humans, right? But suppose one company, one organization is going to employ some robots as well, because this is the era of artificial intelligence. So just imagine that some employer is going to employ some of the robots as well for the work, right? So in that case, if you are going to create a class robot, robo worker, if you are going to create a class robo worker, and you are going to implement class robo worker implements worker, then in that case what will happen, this class, which is robo worker class, this class has to implement all these three methods: calculate pay, assign work, and assign leaves. But the problem is that this robo worker doesn't have to do anything with the calculate pay, because we are not going to pay anything. There will not be any bank account for it, right? Assign leaves, we don't need to track the leaves for the robot worker, right? So these two methods unnecessarily need to be implemented by the robo worker. So such kind of interface, in with respect to this requirement, such kind of interface, which is known as the worker, has become a fat interface. And what are those fatty elements? These two methods, calculate pay and the assign leaves. These are the two fatty methods which we need to remove. Once we remove these two methods and create another interface which can be implemented by robo worker only to have some work assigned, then in that case we will be following the interface segregation principle. So what we can do, we can do one thing. We can break this interface. We can this interface will become obsolete now. We are going to remove this interface, and rather we are going to write two interfaces. One interface will be robo worker, or rather than robo worker, we can write like yeah, we can write like robo only, interface robo. And here in the interface robo, we can give two methods, only one method, void assign work, right? So this will be one of the methods, assign work. And the other interface I can write like interface manual, humans. So I'm going to write second interface, which is humans. Okay, so here I'm going to write two methods basically, void calculate pay, and the other method will be void assign leaves. Okay, these are the two methods which are needed here for the worker. Okay, for the human worker, calculate pay and assign leaves, right? Assignation of work is also needed, right, for the humans as well, right? But what we can do, in case we are going to create a class, which is going to implement the methods for the human workers, then in that case you can implement both the interfaces, right? So class human worker human worker implements robo comma humans. So both the interfaces you can implement in one go. So if you are going to implement these two interfaces together, then you will be able to achieve all the functionalities for the human worker, right? But if you have to write one class which is only specific to the robots, then what you will write, class robo worker implements, what it implements, robo. Okay, now we are going to do this robo worker, and then we are going to implement void assign work. So these are the way you can write your interfaces. You can segregate your interfaces basically, and you can implement your methods based on your needs. So here you will implement these two methods. Apart from that, you will implement one more method which is known as the assign work. So void assign work. So all these you can implement for the human worker. So this is how we have created the interfaces which are very specific. Now we have segregated the interface to perform the specific task, right? So this is how we can do this. We will see more examples. We will see some real life examples in, more elaborative manner when we will be writing the code, when we will be having the videos or the classes on the examples of this interface segregation principle, right? So I hope you must have enjoyed it. You could have understood the basic concept related to the interface segregation principle. And with this particular video comes to an end, and I would request that if you like my videos, please if you like it, please like my video. Please subscribe my channel and press the bell icon so that you can get the notifications whenever you need, right? I mean, whenever I put the new videos, right? So in the coming days, I'm just going to bring some new concepts as well, some new topics as well to discuss, which will be related to the API related things, API related stuff, and related to Python, how to create the API, how to test them. So all those things also I'm going to bring for you. So with this, I would like to say